Okay, so we're going to do area and perimeter of polynomials. So hopefully for a rectangle, you remember the formula for perimeter is 2 times the length plus 2 times the width. And that's for any given rectangle, that's the formula for perimeter. So that's our initial setup. And lost my colored whiteboard marker. There we go. So when a coefficient sits outside of parentheses, you distribute it in. So you're going to get 2x minus 6 plus 2x plus 12. And now you're going to combine like terms. And you get 4x plus 6 units. And that's an expression for the perimeter of this rectangle. Area for any rectangle is length times width. So you're going to multiply length times width, and hopefully looking at this you realize, oops, tiny error, you need to FOIL here. So you're going to do x times x is x squared, x times 6 minus 3x minus 18. Now you're going to combine like terms, and you're going to get x squared plus 3 minus 18, and with area, units are always squared. Let's do one more of these and then we'll move on to triangles. Let's use, let me get a better marker, this one's not amazing. So why don't we do this 2x minus 1, x plus 4. So first we're going to find perimeter. Notice it's helpful to write the initial equation. It's important so your teacher sees where it's coming from. Any careless errors it helps avoid because you set it up correctly. So the length is, there we go, and hopefully you then see you need to distribute that in. So you get 2x plus 8 plus 4x minus 2, combining like terms, x's to x's, 2x and 4x is 6x. Constants to constants, 8 minus 2 is 6, and its perimeter, so it's 6x plus 6 units is the expression for the perimeter of this rectangle. Now we're going to go to area, and as we covered previously, formula for area of any rectangle is length times width. We have our length, and we have our width, and hopefully you recognize this is a foiling problem. So we're going to get 2x squared minus x plus 8x minus 4. And now we need to combine like terms. And in this case, we only have the center terms that are alike. And negative x plus 8x is 7x. And area is always, whatever the units happen to be, squared. And that's area and perimeter using polynomials for rectangles. Now we move on to the triangle. So for a triangle such as this, and in this particular case we're going to only deal with right triangles. So we're going to give this, why don't we do 2x plus 4, x plus 3, and 4x. So we're going to start with perimeter because that's usually the easiest for students. And perimeter of a rectangle is just side 1 plus side 2 plus side 3. So if we were to build a fence in a rectangular area of given dimensions, you would add the sides. So in this case, we're going to get x plus 3, 4x, 2x plus 4. And because you're adding, it doesn't matter which order you put the sides in. It comes out the same in the end. So we're going to combine like terms. And if you had gone from this step straight to this step, that would be completely acceptable. So we have like terms, x plus 4x plus 2x is 7x, and 3 plus 4 is 7. And as we covered, perimeter is units. That's an expression for the perimeter of this rectangle. Now we're going to move on to area. Now, in this case, the height of the rectangle is the side that's perpendicular to the ground, unless you're dealing with a non-right triangle, which is a whole nother story. So you have your base and your height. And there we have it. Now you have a couple choices here. You can FOIL and then distribute in the half. Or in this case, if you notice, half of 2x and half of 4 are constants, non-fraction constants, so that makes it pretty easy. So in this particular case, I'm going to factor in the half. 1/2 times 2 is x. 1/2 times 4 is 2. Now we have a fairly straightforward foiling problem. So you're going to do the first, which is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. We're going to add like terms. And that's going to be 3x plus 2x is 5x plus 6. And that's area, so it's units squared. Let's do one more triangle. And that will conclude our lesson. So why don't we do, now notice the orientation of this triangle is slightly different than the previous example. So here is the perpendicular, so that's going to be when we do area, when we do the height. So why don't we make this x plus 4, x plus 6, and I don't know, let's do, how about 8x? So we're going to start with perimeter. Noticing I'm setting it up with the initial equation. Helps keep it clear in your head, and it also helps avoid careless errors. So we're going to do adding each side together. And now we're going to combine like terms. So x's to x's, 8x plus x is 10x. 4 plus 6 is 10. And don't forget, in this case, I just used units for units. So for area, notice base, height, because that's the perpendicular section. So we're going to do x plus 4 times x plus 6. Now notice here, if like in the previous problem, I distribute this in, I'm going to get a fraction, which makes it a little more difficult to FOIL. Either way you do it, you're going to get the same result in the end. I'm going to start by foiling this portion. So I'm going to get x squared plus 6x plus 4x plus 24. I'm going to combine like terms. And at every step, it's helpful to always combine like terms. And now I'm going to distribute in the half. And 1/2 times x squared, a little awkward, but that's okay. 1/2 x squared. 1/2 times 10x is 5x, and 1/2 times 24 is 12. And as we discussed, area is always units squared. And that's an expression for the area of this given triangle. And that concludes our discussion on area and perimeter of polynomials.